All right, so this is the general power rule, and it works with functions. And so this is our rule for it. So you can see it's f prime of g times g prime. And so what that means is you have some inside function there, g. And so we're going to get f prime of the, and leave the inside alone, and then times it by the inside prime. So we get f prime of inside times inside prime. So if you look at it, think of it our general power rule here. We have an inside with a power of n. So we would bring the n down, subtract 1, and you see the inside doesn't change. And then we multiply it by the derivative of the inside. So whatever's on the inside here is just staying the same. So we're going to leave this alone. And so our derivative would be 5 parenthesis, and then we leave the 2x cubed alone to the power of 4. And so the last step now is to multiply it by the derivative of that. And then we simplify. So y prime equals, this would be 5, and then this is 16x to the 12 times 6x squared. So our y prime would equal 480 x to the 14. Now obviously we could have just simplified this and made this into 32 x to the 15. And then we take our derivative, and so 32 times 15 is 480 x to the 14, and we get the same thing. So it's always quicker to simplify if you can, but it's an example of chain rule. So let's try another one using our general power rule. So what I like to do is take that inside and rewrite it off to the side like that. And then come back and take my derivative. So this would be 6 parenthesis 2x plus 1 to the power of 5, leaving that inside alone. So again, you treat it as if that's the variable, that's your x. And so we get 6 parenthesis 2x plus 1, and then now we're going to multiply it by the derivative, whatever's on the inside. And so we come over here, and we have our inside already pulled out. So the derivative of 2x plus 1 is 2, and so that's what we multiply to our function, our derivative. And so we get f prime of x, well, it is the derivative, is this. And then you take that outer number and the 6, the 2 and the 6 makes 12, 2x plus 1 to the power of 5. Now the reason we're not expanding this one is it's going to get huge. This is a binomial expansion to the power of 5, where this is just one term. So we want to leave these alone. This is where chain rule comes into play, is when you have an exponent that's large with a binomial or trinomial or some function inside that you don't want to expand with that exponent. And so that is our derivative. All right, so to kind of give you an idea of what's happening, let's think of it like this. If we have x plus 1, let's do a 2 in front, to the power of 5, and this is our f of x. What we can do is rewrite it as f of g of x equals g of x to the power of 5, with our g of x equals the 2x plus 1. So we're replacing the inside right here with another letter. Okay. So let's make this look a little different. We're going to call it back to f of x, and we're going to do it as a short form now. This is g to the power of 5. Okay, so it's just we got rid of the parenthesis x. It's not technically correct, but because that's an x and that's a g, but you get the idea. Okay, so our f of x is equal to this. We're saying f of g of x. This is equal to f of x here. Okay, so if you think about it, if we take the derivative of this, it would have to be with respect to x. So what we have to do is a little work here. We say df dx is equal to f prime of x. And so if I take that df and I put a dg under it and a dg under it, what we end up having now is a derivative of f with respect to g. That's our letter here. And then you have to multiply it by the derivative here. And see what's happening is these two are canceling, giving us the same df dx. So what we end up with is our f prime of x is equal to, and then we're going to take the derivative of f with respect to g. So that would be 5g to the power of 4 times, and then now we got to take the derivative of g with respect to x. And so that would be our g prime. And so see, you're getting that same rule as we're getting here, is we take the derivative and then we multiply it by g prime. So if we were to go back now and plug in what g is, we would still need g prime. So we go up here, our g prime of x is equal to 2. See, the whole idea is we're not taking the derivative of the inside, we're taking the derivative of the function with respect to x. So we've got to make sure that that travels. So we treat g as a function itself and we take its derivative first, but then we still have to continue by taking the derivative of that g to make it work. And then that gives us 10 2x plus 1 to the power of 4. So that's all that's happening. You're taking the derivative of this as if it's some random letter. So we get 5g to the power of 4, but because that is not the letter we want, we have to do g prime after it. There you go. Hopefully that makes sense. Oh, we got to write f prime. F prime of x equals that. And so you can see it's 5, take away 1, times 2, and so we get 10. All right, we'll do more in the next video.